Saxon Algebra 1, Lesson 80. Students, let's begin operating, mwahahaha, like surgeons, with scientific notation. We do not add or subtract with scientific notation. In the scientific contexts that we usually use this, we're not trying to add or subtract the numbers. We're multiplying and dividing. That's what scientific notation is good for, not adding and subtracting. All right, but it is very helpful with multiplying and dividing. So that's what we're going to work on. First, we're going to just do straight multiplication, and then we'll weave some dividing in. This lesson it's a little long. It has 5 examples, but it will give you some really strong practice in getting these problems in your head, which is, the goal. 80.1. Write these numbers in scientific notation and then multiply. Okay, so first we get 2 numbers. Well, they're long. They're in what I call sloppy scientific notation because they're kind of partway there, right? They've got the times 10 with an exponent, but this 3 needs to be in the ones place, and it's not. It's over here. So we're going to have to fix that. But let's look at both numbers at the same time. And then 2 times 10 to the 20th. This looks fine, right? This one's ready to go. Our largest significant digit is in the ones place, times 10 with an exponent. Beautiful. This guy is, crazy. So let's fix him. This decimal should not be here. We want it to be there. So we need to move it 1, 2, 3 times. So right now we're writing this as 3 times 10 to the 3 jumps, but are they positive or negative jumps? And this is again how we work ourselves. Here it is as a single digit. When we move it back to its standard form, do we want this number to get bigger or smaller? Well, it needs to go back to 0.003. So it's going to get smaller. That means we need the minus sign. Okay? This reflects just that much. But now we need to bring this into play. And so now we're combining them. So the 3 stays the same, times 10 to the n, as you guys know, because you have memorized that beautiful rules for exponents chart. You know that this is a beautiful example of the product rule. We're multiplying matching bases. That means we add the exponents. So this is a much cuter version of that. Okay, this one is perfect scientific notation. It's no longer sloppy scientific notation. All right, now we're ready to multiply these 2 numbers together. So I'm going to leave that one there, and then I'm going to write this one here just so it's a little closer and looks like an actual problem. This is the way we typically show multiplication in scientific notation, is we put them in parentheses and squish them. Okay, here's what we do. Step 1. Multiply what I call the lead numbers. 3 times 2 equals 6. 2. Add the exponents, and this is again the product rule in action. I'm going to breathe for a second because I'm writing too fast. I get so excited, you guys. I just start writing really fast, and then I'm like, oh my gosh, they're trying to keep up. It's the worst. It's the worst when you're trying to keep up. All right, so I'm going to breathe for a second and let you catch up. So again, what we do, just like we did up here, we recognize we're multiplying 2 numbers that have 10 as a base, and those are the exponents, so we can add them. And we get, let's see, it's minus 7 plus 20. That becomes 13, right? Now we take this, and look how we use them. 6 times 10 to the 13th is our final answer. Yay, and it's right. Okay? So the real hassle of these problems is getting both of them into perfect scientific notation. So I'm going to make that step 0. Scientific notation. All right. I'm not trying to be cute with step 0. I just realized I should put that in first. So you do that one first, then that one, then that one. All right. I should have not numbered them 1, 2, 3, but I didn't think to write that down. All right. Let's do another one. Example 80.2. Multiply. Oh, there's so many zeros in this one. 4 zeros after the decimal, and then a 4. Oh, I shouldn't have put that yet. Times 10 to the minus 5. Now we end the parentheses, and then this number is 700,000. Okay? So our first step, like before, is to get these numbers in perfect scientific notation. I want you to pause me and write each of these numbers in proper scientific notation like we did here. And then when you're ready, you can unpause me and check your answer against mine. If you feel completely lost or that just sounds way too hard for you, then I guess you can watch me do it. But I really want you to try doing it on your own. So pause me. Bye. Okay, now you're back, and I'll go ahead and do it. Okay, there are my 2 perfect scientific notation factors. Now we're ready. So we did number step 0, if you will. Now we're ready to multiply and get the 2 lead numbers. It's 4 times 7, and that is 28 times 10 to the minus 10 plus 5 is minus 5. Okay. Last time I made a point of writing it all out separately so you could see how I did it, but this is fine. You don't have to do that. Now, this is our answer, but there's one little problem here. Look at our lead number. When we multiplied, those 2 single-digit ones-place numbers got bigger, and they created a number in the tens place, a digit in the tens place. So we have to adjust this again. This is how you handle it. The decimals here, we need to move it there. So this becomes 2.8 times 10 to the first power. And then we have to include this. So our final answer will be, I'm going to write it this way so I can write it bigger here. It's going to be 2.8 times 10 to the minus 4. Does that make sense? Right? So you have to check at the very end there and make sure that your cute little ones place numbers didn't run away from you like this one did. Well, it's okay if they run away. You just have to whack them back down to size. That's how I always think of it. All right, so that's our final answer here. And again, we moved the decimal place and then we adjusted the tens for the 3rd time. Beautiful. Okay, now we're ready to try a little division. The division there's the product rule. Guess what other rule we're going to use when we do our division? You're right, the quotient rule. This is product, and this is quotient. Write them down one more time. I know you know them, but you know what? This is how you'll really remember them, is to keep writing them. Beautiful? Okay, so we put those handy because we know we're going to need to use those. All right, 80.3. Divide My book feels crooked to me. This is what the instructions say. Divide 0.0016 by 400,000. Okay, now the first thing it really helps to remember is, what does that even mean? How do you arrange them? Something by something means this on the top and that on the bottom. We want to write them in fraction form, not like in a division box like we learned for long division. We want to make them into a fraction. So it's going to be 0.0016 over 400,000. What was that? I don't even know. Okay, so now what we want to do is, just like we did last time, it's the same exact steps. We're going to fix both of these so they're written in proper scientific notation. This one will need to move 1, 2, 3 times. So it will be 1.6 times 10, and that will be the minus 3. This, 1, 2, 3, 4, 5, 4 times 10 to the 5th. Positive because we want the 4 to get bigger as we go back. All right, beautiful. Well, that's looking really good. Now we use the same idea as last time, except instead of multiplying, we divide, right? So we do, for our step 1 to match to our numbers before, it's 1.6 divided by 4. That's going to be 0.4, isn't it? Okay, so this will divide down and we will get 0.4 times 10. And then we're using the quotient rule here rather than the product rule. So it's going to be minus 3 minus 5, right? We subtract. Top one minus bottom one. So minus 3 minus 5. And that gives us minus 8. Okay, that is really lovely. And it's perfect so far. But again, look what happened here. This was fine. We had a digit in the ones place. This was fine. We had a digit in the ones place. But when we did the division, that guy got too small. So now we have to adjust him back up. So this becomes 4 times 10 to the minus 1, right? Because it started out as a minus 4, and we made it bigger. So this minus sign tells us to make that smaller. Times 10 to the minus 8. So our final answer is 4 times 10 to the minus 9. Here we use the product rule again. See how useful those rules are? That's why I forced you at gunpoint to memorize them. I mean, it wasn't gunpoint, but you know. Okay, now we're going to do super duper fun of combining, multiplying, and dividing. And this is what most of the problems we're going to do in the future will look like. All right, simplify. The hardest thing about these problems for me is counting the zeros. There are 3 zeros between the decimal and the 7. Times 10 to the minus 23. Okay, there's the numerator. Now, here's a little trick that I want to show you. What I do is I leave some space and I draw the fraction bar down a ways, and then I write the denominator skipping more space, and I'll tell you why in just a second. I'm going to scoot this up a little just to make sure you can see that pretty well. Okay, this is the original problem. 0.0007 times 10 to the minus 23. I'm just double checking. Skip. Okay, those numbers are correct. Now, notice in the book, John wrote this problem like a normal human being. He didn't put giant gaps in the number, right? In the problem. He didn't spread it way out the way I did. Here's why I did it. I don't want to keep copying these numbers over and over again, but we need it to end up with our numbers above and below this fraction bar. So what I've done is I've given myself room to work from the top down and the bottom up so that I will get my perfect scientific notation written just above and below this bar, and then I'll do my final steps. Well, it's right here close, all organized in a neat way. All right, so you'll see as I do it. But I did it to make it easier so I don't have to keep rewriting the bloody problem because I don't like doing that. 1, 2, 3, 4. 7 times 10 to the minus 4 times 10 to the minus 23 means that this number is 7 times 10 to the minus 27. That's a 7. Got a little messy. Okay, so now that is my adjusted, cute, perfect scientific notation, and it's sitting right here on the division bar where it will look normal when I get all of his friends gathered together. Let's do the same thing here. 4,000, 1, 2, 3. 4 times 10 to the third. Then we combine it with the 10 to the 6th. 4 times 10 to the 9th. Are you sort of getting the vibe of this? Now, I don't need that space in between, but that's just how it worked out. It's fine. I'll leave it like that. All right. And now we go down to the bottom. These I'm going to work up, okay, so that my answers will end up right here with their friends. Okay, ready? 1, 2, 3, 4, 5. 4 times 10, it's a minus 5, right? Because the standard notation is much smaller. And then this one will be 7 times 10. 1, 2, 3, 4, 5, 6. Positive 6. All right, this is what I like because here, I'll draw a box around it, but it's not the answer. But now I've got the simplified version of my numbers right here so I can see them really closely together. And sometimes I'll even do this, just lightly cross this out so it doesn't confuse me. Don't scratch it out because I might need to look back at that. But that helps me focus in on what I've got here. Okay, now I'm ready to simplify, but what I'm going to do is I'm going to use my little overflow book because I don't want to turn the page away from these numbers, all right? So here we go. The first step is to organize it all. The next step is to gather up all of the numbers. So look what we have. We have 7 times 4 over 4 times 7, right? 7, 4, 4, 7. Well, you can either cancel those all out or you can multiply them through to get 28 over 28. But all of those cancel and we end up with just a 1. Wow, that's pretty cool, right? And then we're ready to deal with our numbers. Now the way that we do that is it's going to be minus 27 plus 9. And then we have to subtract the ones that are in the basement. Minus a minus 5, minus 6, right? So we add the ones in the top and subtract the ones in the basement. That minus sign was already there. So I didn't put that there. That was just the number there. I add the 9, I subtract the minus 5, and I subtract the 6. That's a little bit mind-blowing-y, but we're just using these rules, okay? Now, I'm ready to simplify this. Let's see, this is going to be a plus. So I have 2 plus numbers and 2 minus numbers. Let's put all the pluses together. Plus 14 and minus, what, 33? Which means that those add together to give me what? Negative 19. Right? Let me squiggle. That means I use them. So my final answer over here is 1 times 10 to the minus 19. Remember, I'm not doing these on scrap paper because they're not important. I did them here so you could see everything in one place. I don't like to turn the page in mid-problem because then you lose all the good stuff. There's our final answer, you guys. Yay. We'll be doing lots of problems like these in the future. We'll add some new little wrinkles to make them more challenging. Won't that be fun? In the end, you'll be doing these on calculators when they get really hard, but now we don't need a calculator. John keeps the numbers safe and cute, right? Like how fun is that, right? He keeps things manageable so that we don't need them, and later he'll give us some crazy numbers and we'll have to sort it all out, and we'll desperately need a calculator then. But now is not that day. Okay. Goodbye, auxiliary notebook. Let's do one more problem. Example 80.5. And again, let me show you the problem. We have 4 chunks, and the top 2 are being divided by the bottom 2. I'm going to do that same thing where I'm going to spread them out, and I'm going to make space to work toward the middle so that it'll end up being neater than it is to start with. And I don't have to rewrite it. Okay. Make sure you're writing neatly enough and big enough so that you can see your exponents really clearly, but you also know that they're exponents and they don't just look like big chunky numbers, right? You don't want it to look like this. That's way confusing, right? You want to make sure it's clearly an exponent. 400 times 10 to the 20th. Leave some space to work. Leave some more space to work. Okay, I'm double checking just to make sure I copied accurately. Okay, that looks good. All right, if we were together, I would make you do most of the work of simplifying these, and I would sit in the chair and watch you and stare out the window and daydream. Just kidding, I wouldn't. I would help you. But you're not here, so now I have to do it all by myself. Oh my gosh. Good thing I like doing it. You guys, it's really weird how much I enjoy teaching math because I think it's really fun doing these problems. And I like trying to explain it. Like it's a challenge, right? To try to explain all of these complicated, horrible things. I know they're complicated and horrible. You'll never get me to deny that. But it's fun to try to think of how to explain this in a simple, straightforward way. So this is my idea of a really fun time. I'm sorry. Okay, the decimal's here. We want it to be there. We have to jump it once. This becomes 2 times 10 to the first power because we want to make 2 bigger, so that's a positive number. But we also have to combine it with what was already there, and so we get 2 times 10 to the minus 44. Agreed? Yes. You know what? And I want to say this. With these problems, it's really important when you get all 4 numbers simplified here and in perfect scientific notation, especially these first few weeks, or lessons, not weeks. Stop and check the solutions manual to make sure you've got the 4 factors correct before you go into those last steps of pulling out the numbers and simplifying the exponents. Because it's so sad if you get it wrong and you make a silly little mistake, but then it all gets tangled up in all the rest of the problem. No, check it before you go. Okay, 1, 2, 4 times 10 squared. We want to make the 4 bigger, so that's positive. And then times 10 to the 20th. So this is 4 times 10 to the 22. All right. Now we're down here. Now this one isn't being multiplied by a 10 to the something, so we know that this will just go in one step. We don't have to do this 2-step thing. And this will be 1 times 10, 1, 2, 3, 4, 5, to the 5th. Always draw out your jumps. When you get better at this, more experienced at this, you'll go faster and students want to like skip over that. Please don't. Please show your jumps and actually count so that you don't make a silly mistake, because that would make me cry. 1, 2, 3, 4. Oh, I'm not up there yet. 8 times 10 to the minus 4 times 10 to the minus 15 gives me 8 times 10 to the minus 19. Okay, this is the point. And then go ahead and do something like this so that you focus in on exactly where the problem is now. It's so satisfying to have all of the weird previous steps squished to the top and the bottom and just what we need right in the middle. I'm double checking. Yep, everything looks good. So now we will pull together I call them the lead numbers. And I'm labeling this so that you can follow me. That says, yeah, that's lead. I thought it said lead. It's spelled the same. Like lead pipe. Okay, 2 times 4 over 1 times 8. Look, it all cancels. That becomes 8 over 8. So once again, our lead number is going to be a 1. John is being so nice to us, right? And then the exponents. Okay, remember we add the top ones and subtract the bottom ones. So it's it's minus 44 because that's a minus sign. That's a minus 44 plus 22 minus 5 minus a minus 19. Okay, that one's negative because it's already negative. We add the 22, then we subtract what's on the bottom, minus 5 and minus the minus 19. So this turns into a plus 19. So we have 3 numbers that we're adding. That's 66, 85 minus 5 equals 'Oh, I see what I did wrong. That's a minus 44, and I treated it like a positive. Okay, see, it was just messy. Okay, so the positives are the 22 and the 19. That is what, 41? And then the minuses are the minus 44 and the minus 5. So that's minus 49. So that equals negative 8. Make sense? That got me in trouble. I knew it would. So my final answer is 1, this one, times 10 to the negative 8. My lead coefficient, my significant digit, is still just in the ones place. It didn't go too big and it didn't go too small. We've seen both of those dramas. That is the right answer. Yay! I almost fell in the trap with my broken looking minus sign. So don't be like me, kids. But yeah, there it is. So lesson 80 is in the books. We're going to be doing these for quite a while. They're kind of long and they're kind of messy problems, but you know what? Every time you do one of these, I want you to lean back for a minute or whatever you can do depending on how you're sitting. And pat yourself on the back because look, that looks really hard, doesn't it? That is not an easy problem. That is some serious algebra going on right there. And I am very impressed with how you are keeping up because we have been moving fast for the last 25 or 30 lessons. It's been a brisk pace and you guys are doing a great job. So keep it up. I will talk to you soon. Farewell.